All right, so cube root parent function is f of x is the cubed root of x, just like how you think, cube root function. We're going to graph this the same way that we did up here using a table. And instead of plugging in perfect squares, I'm going to plug in perfect cubes. So what I like to do is I like to figure out what kind of values do I want to get out first. What kind of y values do I want? So let's look at this parent function. If this is a cube root, which means it has an odd index, I can have both positive and negative outputs, meaning I can take the cubed root of something negative and get out a negative number. This is not like the square root, where square root was strictly positive. Cube root, I can have negative and positive numbers. So with that said, I want to get out -2, -1, 0, 1, and 2. Okay? So that's what I'm looking for when I graph. Basically, instead of putting these as my x's, because I don't know what the cubed root of -2 is, that would be icky. I don't want to try that. I want to know where on this graph does the function equal -2. Okay? So the way we're going to do this is we're going to cube each of these numbers. Okay? Since this is a cube root, we're going to do the opposite, and we're going to cube them. Okay? So -2 cubed, that, you don't have to write this down. I'm just going to show you what it looks like. -2 times -2 times -2. Negative times a negative times a negative is negative. 2 times 2 times 2 is 8. Okay, so that's what we're doing. We're cubing them. -1 cubed is -1 times -1 times -1. Okay, 0 times 0 times 0. 1 times 1 times 1. 2 times 2 times 2. All right, so now we have points that we can plot. Okay, and you're going to notice something about this graph. So if you notice that the square root looks like half a parabola, this is going to look like the cubed function turned on its side. That's what you'll notice. So it's not going to be a straight line. It's going to be the cubed root, the cube function turned on its side. So -8, -2, 8, -2, -1, -1, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 2. So this function looks like this. See how it looks like the cube function turned on its side? Okay. That is what the cube root parent function looks like. Okay. So its turning point, so this one doesn't have an end point because it goes on forever, but its turning point is the very, very center of the graph. So it would be 0, 0. Another way you can look at that is where do the numbers start becoming opposites, mirror images of each other? Right around 0. Okay, its domain, I can plug in both negative and positive numbers, so that's all real numbers, which also means my range is all real numbers. I'm at school on a Wednesday during break, so that's why the bells are going off. Okay, so that's the cubed root function. So in the next video, I'm going to talk about how we can transform these parent functions.